Hello all, welcome to the SecurityTube Linux Assembly Expert course and certification. Now in this video, we will look at RIP relative addressing. Now RIP relative addressing is a very important concept in 64-bit shell coding. Now most importantly, this is only available in 64-bit mode, and the whole idea here is to compute addresses relative to RIP's current value. Now, as you can well imagine, most of shell coding really deals with finding addresses of data like the hello world string within our shell code and then using it. Now, with RIP relative addressing, this becomes really very simple because when we create the shell code, we can reference the data relative to what the position of RIP would be. Now, the whole idea was to be able to write PIC or position independent code. From a shell coding perspective, RIP is really a huge advantage, as we will see. Now, in order to use RIP relative addressing, there are really two options. One, you can go ahead and use the default directive with the rel keyword, which ensures that basically RIP relative addressing is applied. Or alternately, when referencing any specific variable or any label, we can go ahead and use the rel keyword before that to basically tell NASM that this is supposed to be computed using RIP relative addressing. So let's take up an example of writing the hello world shell code using RIP relative addressing. So I'm going to copy our old hello world.nasm, open it up. And let's say we can make this string a bit shorter just to make our life a little easy. Can remove the length, can remove the data section. Now the length of this string is 5, 10, 12, 13. Looks like it's approximately 14 characters. You can just put this in manually for the time being. Great. Now, in the case of RIP relative addressing, we can basically go ahead and convert this into an LEA and just use the rel keyword. And now this becomes RIP relative addressing. Now let's fix the shell code. So RAX, and add RAX1, remove this, and then basically move RDI RAX. So RDX, add RDX14. This can just be our familiar. So RDI. Can we have a ZOR RAX? This could be an RAX60. There we go. Now let's go ahead and assemble and link this. If you run it, there we go. We see hello world SLAE-64 getting printed. Now let's just go ahead and copy shellcode.c in here. Use the cut command to get the shell code. Of course, this does contain a couple of nulls, and tell you why in just a second, but we should still be able to execute the shell code. That isn't a problem. Just to verify that works. And there we go, right? Works perfectly. However, if we use object dump, we would actually find that all the zeros is really in here, right? In the RIP relative addressing part. If you notice, it says RIP plus 15 and hex to go ahead and reference basically the data which is in here. But the problem really is these zeros cannot be eliminated simply because of the fact that we are reading ahead and that the hello world string is defined after the actual RIP relative addressing happens, right? So in the next video, we will look at how to eliminate this condition and not have these zeros. Now in this video, let me just touch upon the other way by which we can go ahead and say that we want to use RIP relative addressing. This is basically just using the default rel statement. There we go. You can use object dump to verify that RIP relative addressing has been applied, right? Now keep in mind that if we do not apply this, which is either the default rel or the rel keyword in here, then absolute addressing is what would be applied. So now if I use object dump, you would immediately notice that here now we have the actual address in there, which would fail in the case we want to use it within a shellcode, right? Because it's a hard-coded address. So this is a very important concept. So keep in mind that either you'll have to mention default rel on top, or you can mention it specifically the place where you want it to be applied, right? Fantastic. So that's all for this video. In the next video, we will look at how we can go ahead and remove these zeros. So hopefully you've enjoyed this video, and if you like what you see at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.